Today we're going to take a look at another option you have for auto bed leveling on your 3D printer. It's called the Euclid Probe. Hello everybody, Chris here. The Euclid Probe is a unique little device that I first saw back at EARTH 2022. I talked to the folks over there and they gave me a kit to check out. Now, of course, things happen and I don't get around to things as fast as I should, but I definitely wanted to try it because of the way the Euclid Probe works. Basically, it's a couple of PCBs that attach via magnets. You can go grab it, it has a micro switch on it, you can use it for your bed leveling, and then it puts it back in a dock. It's a very unique setup. I really like to watch it work, but there is quite a bit to being able to get all this set up. It's not everything in one kit that you need. So that's what we're going to do today. We're going to walk through all the steps I took to get the Euclid Probe up and working, the things you have to change up on your 3D printer, and why you might want or not want to use a setup like this. So let's just start by seeing the probe in action. So here's my Ender 3 version 1, just a regular old Ender 3, not much to it at all, but I've got the Euclid Probe set up on it already. We will walk through the steps, but I wanted to give you the lay of the land first. You have the PCB side that's mounted on the side of your Hotend carriage. There's a set of magnets that are controlled here. You have wiring that run back to your end stop on your main board. And then you'll also notice that we moved the Z end stop to make it a Z max end stop. There's some advantages when using this setup to homing at the top of the printer, so you know exactly how far you have to go down to start printing on the bed. And then you have your dock over here with the probe in it. This is the dock that the Hotend carriage can go grab this probe, and then it has a micro switch, just a regular click type switch that it uses to probe the bed and build that bed mesh. Now this is not the easiest setup to get working on your 3D printer, but depending on the type of printer setup you have, maybe you have a custom install, this might be really handy to be able to store your probe when it's not in use. But it's well worth our time to run through it so you can see how the whole thing works. And just so I can show you the process, we'll go ahead and auto home. It's going to take the printer all the way to the top. There have been some firmware configuration changes on this. It's going to take it all the way to the top to our new end stop location and home it. And because we're homing at the top, like I said before, now you can control the distance to the print bed with the Z height, basically. It just makes it a little easier to use this just for mesh building, not to home the printer. But now we can go ahead and tell the printer to deploy the probe. You can also just do bed leveling and that does the whole sequence. So let's just run through that. We'll just hit level bed on the LCD. After some configuration changes, you can set the dock location. It's going to go down to the printer and grab our probe. You can see when the magnets get close, it'll try to grab it out of that dock even before it gets there. They're very strong magnets. And then it will continue down and push that probe out of the dock. Now it's going to go through a regular bed leveling sequence. 25 points in this configuration. Kind of the cool part about this probe setup is if those magnets aren't attached, it knows that the probe didn't get grabbed correctly, and it won't complete the cycle. So it is at least a little bit smart in that regard. Once the probing is complete, it goes back to the dock, puts the probe away, and now it's available to start the printing. So in practice, I really like this setup. I enjoy watching it work. But on an i3 machine, it might not be the best solution. It is a little bit fiddly trying to get everything set up just right so that it's able to grab the probe and use it. It might not be worth going through all the trouble. But again, depending on your printer configuration, this might be a great solution. So it's well worth going through the time of showing you how I got it set up and all the configuration changes you need to make to get this working. So let's jump into the nuts and bolts. So you can get the Euclid Probe from a lot of different vendors. I headed over to Fabrico just so I could show you what was in the kit. You can get a kit version or the fully assembled one, meaning you don't have to solder anything up. But with the kit, it does list as 24 volt. So you can operate this from anywhere from 3.3 volts up to 24 volts. I am doing 5 volt today because I'm running it from the end stop. Now, different voltages are going to have some drawbacks. I suggest you keep it at 3.3 or 5 just to protect your main board. But here's what you get in the kit. It's a micro switch, a couple of connectors, a few magnets, and a PCB to put everything together. Remember, you just have two portions here, the dock and then the probe itself. And on the Euclid Probe website, they do have a fairly straightforward set of instructions that show you what all the parts are and how to get everything assembled if you want to go that route. They also have several printed parts that can help you along the way. And I'll try to show you all the ones that I used as I build it. So basically, to start here, we have a 3D printed jig. This does greatly help you keep everything together while you're soldering it up. But you have a connected PCB, and then we just put our parts in this jig. On one side, it's going to be a JST connector. And on the other side, you'll have your micro switch. And you want to make sure you put the micro switch in the correct direction. For an Ender 3, you want the switch side on the pointed end of the PCB, so it's closer to the nozzle. Depending on the printer configuration, you might want to change that up. But now that we have it assembled, we can go ahead and just solder up these connections. Once you have all your soldering connections complete, we'll go through with a set of trimmers and trim them down, just to make sure they don't interfere with any of the mounts. And then we can put some kind of tape on the back, just to make sure the contacts don't touch anything while it's in operation. These should be fairly easy to trim down with some side cutters. And then I just put some small pieces of Kapton tape on the back just to help protect the connections a little bit. And then I just trimmed them down with a razor. And then with all that done, we can move to putting on the magnets. Now the magnets are kind of the tricky part. You have these inserts that you can put in your jig and then put your PCB back on. There will be screws that screw into these inserts that hold the magnets in place. But you have to make sure you have the north and south side of the magnet correctly so that these plates will grip each other. You want to install the magnets so that it can only grab the probe one way. But you can set the PCB back on these inserts, and then one at a time you can screw the magnets on with the screws they provide. You can just put them on one at a time, making sure you have the correct polarity. There is a printed part that helps keep them separate so they don't try to grab each other. And there's also some helpful pictures on the guide that help you keep all of this straight. There's pictures on their site that kind of give you an idea of what we're going for here. It's not difficult to change them up if you don't get it correct, but go ahead and try to get it correct the first time. Then after you get your magnets on, you can pull it out of the jig, and you should be able to just break the PCB with your thumbs. And then you want to make sure you clean up any of the rough edges on the PCB with your side cutters. Again, just to make sure that it doesn't hang up on anything when you're trying to grab it out of the dock. Once everything's all set up ready to go, go ahead and put your probe together. Make sure they're gripping each other correctly in the correct orientation. This is how it's going to look for an i3 style or an Ender 3 printer. I'll show you the 3D parts more here in just a minute, but I did want to make sure that the probe was going to fit correctly in the dock. And then the other side is going to screw onto our part that goes on our hot end carriage. It just has a spot in the base for your JST connector on the other side of that PCB. And they just give you a couple of self-tapping screws that help hold it right into the 3D printed part. Once again, we just want to test it to make sure it can grip that probe. Now we'll move on to all the other parts that are involved. So the idea here is that we have to make our bed stationary. On the Ender 3 stock, it's setting on some springs. We want to put it on some standoffs, so you're able to select that probe easier. It's easier to find where the probe is. But we have some printed parts. We've got the hot end side that we just saw. We have the dock, and then we have the dock holder. It actually sets underneath one of the standoffs. And these standoffs are 15 millimeters long. You can get them a lot of different places. You could even 3D print some if you wish. But outside of those standoffs, we're going to use the stock bed wheels to hold everything together. There's no need in getting nuts or anything like that when you already have the wheel. The stock screws that hold the bed on, and we also need an additional M3x20 and a hex nut to hold the dock on the dock holder. And then a couple of printed spacers that will compensate for those holders on the right side of the bed. They go in between these spacers. You'll see more of that as we get it assembled. So the first thing we need to do is just take everything off of the bed. I did have a full bed on this printer. I'm just going to remove that for this video. But all you really need to do is back all of those bed knobs off, pull the screws through, and disassemble everything, because it's going to have to go back together with some 3D printed parts. So we'll start with the back left of the bed. We just have that stock screw. We're going to put our spacer in place. And you have that part for strain relief for your wires. That adds some thickness on the left side that we have to compensate for with that 3D printed spacer I showed you before on the right side. It'll make more sense in a second, but we'll just attach it with our stock bed knob. And then in the front left, that's where our dock goes in. So you have a part that holds the adjustable part of the dock. That goes underneath the bed wheel. This is the adjustable dock. You thread your M3 by 20 millimeter screw in to a hex nut to hold it all together. So your probe gets held by this part, and this section slides underneath the bed. So we put our hex nut in there and attach the adjustable dock. So once that's threaded together, it'll just go underneath the bed. Again, our stock screw and that 15 millimeter spacer, and just attaches with that stock bed leveling wheel. And then we move to the right side. We have these 3D printed spacers as well as our 15 millimeter spacer. The printed part just takes up the slack for those mounts on the left side. So the front and the back mount exactly the same. Once you have your spacers in there, again, we'll just put it on with our stock wheel. And we can snug all those wheels up. You don't have to get carried away with it. But now the bed will be stationary, and it's going to be much easier to utilize that Euclid probe. And for the hot end carriage side, we're just going to loosen up this top left bolt just a little bit, and the mount can slide underneath it. There's also a spot in the mount where we can back out one of the fan shroud screws and use it to further hold it on there. So we can just slide that screw into our printed part, and the whole carriage just slides on the metal plate and underneath that top wheel screw. And then when you tighten up that bottom shroud screw, everything's nice and snug. You definitely want it to be level so you can grab that probe easily. And then we have to talk about relocating that Z end stop. This is the stock mount from down below. We want to move it up to the top. This is a part I found over on Thingiverse. I'll leave a link. It just goes into that 2020 extrusion. It even has a screw where you can use a T-nut to further fasten it. But it leaves that end stop facing down. You can use the stock mounting screws to put it on the part so that that X carriage collides with it when it's home at the top. Thank you to whoever made this. I forgot to look up your name, but it is much appreciated. So it will just slide into the top extrusion, switch facing down, and there is a 3-pin JST connector. Again, I had to make my own wires for this setup, but on the end stop, you just want the outer wires. And I just used some 3D printed parts to cover up the wires as I ran it down the printer. And then on the board side, it's just a JST connector. It's 2-pin. This is a Big Tree Tech Mini E3 version 3 board. It's very similar to a Creality board, but it's just going to go in your Z end stop pins right here. The rest of the magic happens in the configuration later to make all of this work. And for the probe side on these boards, it's a 5-pin connector. That's so you can use the BL Touch. We don't need all of those pins. We just need 5 volt, ground, and then the Z pin. Think of it like an end stop pin. Again, you'll see that in the configuration. I'll show you all the pin numbers, but this will go in the probe port. The probe port's located right here in the front. And with those 3 pins connected, you can use a 3-pin JST on the other side. There's a look at the connector and the different colored wires that I used. You can kind of line them up. But again, VCC, ground, and then that probe pin there in blue. That end stop or probe port should give you 5 volts to run the LEDs needed on these sensors. So you can see the setup so far. There is quite a bit of work you have to do here, and if you don't like crimping connectors, this might not be the project for you. But I do enjoy trying things like this out on 3D printers. And the work is not done. We do have quite a few different configuration items we need to change to make this setup work. Now, this Ender 3 is running Marlin, and inside Marlin, they have settings just for this style of probe, one where you have to go grab it from a dock to be able to use it. So that does make it easier. But again, there's quite a few things we have to tweak to let it know we have this probe and how to use it. So we'll walk through all of that now. So today I am assuming that you have a configuration that already works for your 3D printer. This isn't going to be a from scratch walkthrough. I am using the example from the Marlin GitHub. Keith has created an Ender 3 Big Tree Tech version 3 board example that works great. We're just going to make the tweaks that we need to make our probe work. Now today we are using Marlin version 2.1.2, and the first option we need to adjust is around line 1048. And that is use ZMax plug. Now, we don't necessarily have a ZMax plug on our board, but to be able to home in Max like we're doing today, the configuration is going to want you to enable this Max plug. So we'll just keep the 3 defaults up here at the top, keep those enabled, and we'll take the comment off of this line to enable ZMax plug. Then we'll keep scrolling, and we need to get down to the Z probe options. The first thing we have to decide is how is the probe hooked up. In the version that we have today, we have to assign our Z probe pin. So it's not the default of ZMin probe uses min instop, because now we have a max instop. We're using specific probe pins, and on this Big Tree Tech board, that probe pin is PC14. Now, depending on the board you're using, you're going to need a pinout of some kind to be able to tell which pin you used for this probe. For a lot of board makers, including Big Tree Tech, the easiest way to do it is to go to their GitHub, and they're going to have a pinout. You can see these 5 probe pins that we used. Go back and take a look at the wires we used, but PC14 was our signal pin, we had ground, and then that red wire was in 5 volt right here. So PC14 is the probe pin that will be triggered when our probe triggers. So we assign it directly here in configuration.h, no problem at all. And of course, make sure this line has the comment removed. It is there by default. And if you scroll down just a little bit further, there's a whole section for magnetically mounted probes, like the Euclid Probe. You just take the comment off of this line, and then when you do the standard G29 sequence to level your bed, it will include all of these movements to enable you to pick the probe up. You can adjust the feed rate and the dock destination. The Euclid Probe website gives you some recommendations on where this probe dock is going to be on different configurations like the Ender 3. I had to play with these settings a little bit so that it would put the probe back and grab the probe successfully every time. And I think the easiest way to find your dock location, what's going to work for your configuration, is to just home the machine and then get your configuration close to be able to grab the probe. I just use something like Pronterface to manually jog the printer where I want it to be to come up with these values. So I'll get the dock close and then bring it down until I see it grab. Once it's grabbed it, I'll bring it down so that it's able to undock the probe, and then I'll move it off the dock and record those sequences. To get where you're at as far as the printer's concerned, you just do an M114. And then you can use these coordinates to plug into your configuration. For instance, to grab the probe, I'm at 60x, Y0, Z3. And you can see in my active configuration, I have to get actually a little bit lower to grab that probe to get it out of that dock. But here's where you plug that in. And it has good comments to tell you what's going on here. Move to the dock, attach the probe, so X60, Y0, Z.5. Then you slide to the left to remove it, 28 for X, Y0, still at the same Z height of 0.5. And then I like to move out of the way closer to the end stop on X, so I go to 5 and then raise up 20 in Z, so I know 100% sure that I am clear of that dock, ready to probe. And then just the reverse when you want to put it back. I move over to the dock to the 60, but I'm still at Z20, just so I know I'm in the right spot. Back to 28, and then I move down, back to 60 to put the probe back on the dock, and then straight up 20 in Z to detach the magnets of the probe. It's pretty self-explanatory, but if you don't know how to jog to those locations and get the values, it can be somewhat difficult. Not every configuration is going to be like this one, but it's pretty easy to dial it in now that you have all of these settings. The next thing we have to be concerned about is the Z probe offset. This is the same for any probe. This setting is where the probe is in relation to the nozzle. Now in Marlin, they give you this diagram that tells you whether it's going to be negative or positive. Today our probe is on the left and in front of the nozzle. So both of those numbers will be negative. And you just can figure it out with a ruler by holding it up to your printer. So it's on the left. We'll just measure from that button on the micro switch over to the nozzle. That's around a 46 millimeter. And the same, since that switch is in front of the nozzle, we're right around 20 millimeter. So those are the negative values we'll plug into our configuration. And I'm just going to set the Z value to 0 because I think it's easier to set it after the fact. We'll just save it in EEPROM. You can come back and update the config later once you have a solid value. Next up, we have to change the Z home direction. Now, minimum is -1 on the home direction. If you want to make it the maximum, you just leave it as 1. So we'll just take off the negative for Z home, because now we're going to the top. And right after that, Z max position. Now, this is going to have to be somewhat adjusted. The default Z height for your Ender 3 is 250, but because that bed is adjustable on those springs, that can vary. Now, with your new 15 millimeter spacers, that should get you to about 250. I found on mine, my bed was just a little bit higher. So I went with 249. So now I know that when we go to max, I have to drop 249 millimeters to get the nozzle exactly where I want it over the bed. So this is the best place to adjust that. Everything after this can be done with the probe offset. So just keep that in mind when you're dialing this in. You might have to adjust this a bit depending on your configuration. Then the next section we come to is bed leveling. We just have to enable the proper one. By default, Keith has mesh bed leveling, that's manual leveling. We're just going to use auto bed leveling by linear, so we'll make sure the comment's off of that. You can only have one, so uncomment the rest. And then below that, you can set your max grid points. This one I'm doing 5, that's a 25 grid, 5 by 5. You can adjust that to whatever you want, I think up to 9 in Marlin right now. And those are all the probe-specific settings that you need to alter in configuration.h. There's a couple of other settings that might make your life a little easier. We'll see how the probing goes, and we might have to adjust those. So we might come back to the config, but now we can go ahead and compile, put this on our SD card, and load it to the printer. And when our configuration has been flashed, you'll have some new options on your screen. In motion, we're going to go ahead and auto home. We'll let it do that cycle, because it does take a while to get all the way to the top. But you'll have deploy and stow probe. These are the easiest way to test that you have the correct location set for your mag style probe. We'll take a look at those as soon as the auto home finishes. So our carriage is all the way at the top. You can see our screen says it's at 249. You saw that in the configuration. I did this manually just by stepping the printer down bit by bit and recording this value to see how far it took it to get the nozzle all the way to the bed. That's how I came up with the 249. But now, let's just test to see it grab the probe. So we'll deploy probe. So the settings we added to define the magnet probe, they're in play. It moved to 60. It's going to come down and grab the probe out of the dock. It's going to move to 28 and then lift the probe out. Now you can see the magnets are actually strong enough to lift the entire bed. And that's not good when you're trying to have a level bed. The standoffs we added should help. It should keep it somewhat tight and allow it to snap back, but still not the optimum configuration. On a bed slinger like this, this probably isn't the best probe to use, honestly, just because of this fact. But if you have a stationary bed, something a little bit more solid, this is going to work much better. But we just kind of have to deal with what we have today. I just want to show you how to get it all set up, how to get it working. But we've deployed the probe, and then let's go ahead and go back to motion and hit stow probe so we can see it put it back. And the probe's back into its seat. We know that this is working, so now every time you run a G29, it's going to do this probe deploy cycle, do the bed level, and then put it back for you every time. You don't have to mess with it from here on out. And we can just go ahead and give that bed leveling sequence a try right from the LCD. Just go to Motion, Bed Leveling, Level Bed. It's going to get the probe. And then start to build our mesh. Now you can go ahead and give it a try, but I wouldn't expect that initial bed leveling to complete because we don't have our offset set correctly. It's going to give you probe failed because it doesn't know how far it has to go to trigger that probe. So let's get that set up now. First, we're just going to home all, and then I'm going to move the nozzle down to the middle of the bed. So I'm going to do G1, X 110, Y 110, and let's go Z10 right over the bed, and then we'll bump it down in small increments, feed rate 5,000. Now we're going to use Pronterface to bring the nozzle down gradually to touch our piece of paper. It's just barely touching, we should be good there. Now I'm going to tell the printer with a G92 that Z is 0.1 millimeters over the bed. It's going to give us a little bit of gap for the filament to lay down. M114 to confirm that it's set correctly. It is. Then we're going to do an M401 to deploy the probe. Then we're going to do a G30 to perform one single probe. And you'll notice the probing failed. That's because the offset is still set to 0. But if you do an M114 now, the printer thinks Z is at 9.71. And effectively, that is the gap in between the switch of the probe and the nozzle. That is your Z offset. You might have to adjust it, but it's a great starting point. So from here, just do M851, Z, negative 9.71. M500 to save. Now your probe is going to work correctly. You can do your auto bed level, and then dial it in after the fact. So from here, you can just start your G29. When the G29 is complete, it'll put away the probe. And then if you have this in your start G code, it'll go right to the print. If we take a look at the bed leveling grid in Pronterface, it's not the worst Ender 3 bed I've ever seen, but it could still use a little bit of help. So good thing we have auto bed leveling. So let's just kick off a quick print. And then we can use baby stepping to adjust the Z offset further. G29 is complete, we'll stow the probe. And then just like regular with baby stepping enabled, you can double click and dial in that first layer, that offset just a little bit further. The first layer is a little close, so we're going to increase that offset a bit with the way the probe is mounted. So we were at a 9.71, I took it down to about a 9.4, 9.41, and the first layer is looking a lot better. Once you're happy with that offset, you can just save it to EEPROM. From the LCD, just go to Configuration and hit Store Settings. And you're good to go. And if you don't have that baby stepping enabled, it is in a lot of configurations now, but it's in configuration_adv.h. Just take the comments off of baby stepping. And then to use it as your Z probe offset, just make sure you have the comment removed from this line, baby step Z probe offset. And then you can dial it in just like any other auto bed leveling or any other sensor. So there it is, the Euclid Probe. And I really do like this setup. I think it's a great idea to have this switch on the PCB. It's very accurate and you can stow it away from the print head and save a little weight on that moving carriage. But this is a completely custom configuration. They're not going to be able to make a Euclid kit for every printer out there. There's just too many variables. And also with the i3 style, just the way you would have to mount your dock like I showed here, it doesn't make it the best option to do this sort of thing. If you had a fixed bed where you could store the dock in a more convenient place, something that was more steady state, it'd work a ton better. So I think there is a printer configuration where this would work the best, just not maybe on the Ender 3. So hopefully you found this interesting. That is it for today, and I'll see you really soon on the next one.